Hello, calculus students. We are continuing with Unit 8, applications of the integral. I know that I mentioned 3 different ways to find volume. So we have cross sections, discs, and washers. I'd mentioned something called shells. Those are actually not tested on the AP exam. So we're not going to spend important class time on those. So instead, we're going to look at arc length and distance traveled. These are BC topics, not AB topics. Students will be able to use integrals to determine the length of a curve or distance traveled. We can use the polygon approximation, right triangles, to find the length of the curve y equals f of x. This process is called finding an arc length. So here's your arc length formula. Now, I just kind of want to pre-warn you that you are going to have 2 other formulas that go along with arc length. This will not be the only one. There will be 3 versions of it. The first one here is in function notation. A little later on, we're going to do one in polar coordinates and then in parametric coordinates. Those happen in Unit 9. So just a heads up, this is not the only version of arc length. But basically, it's formula. You got to put the pieces in. So example 1, find the arc length of y equals x squared over the interval from 0 to 1. So put the pieces in. The length would go from a to b, which is 0 to 1. 1 plus, now note this is the derivative squared. So the derivative of x squared is 2x, quantity squared dx. Now, I want to show you how to do this one by hand because it can be done. So I have 1 plus, actually this one can't be done by hand, I take it back. 1 plus 4x squared dx. I was looking at this and thinking I could use u substitution, but if u is 1 plus 4x squared, the derivative would be 8x, and I don't have an extra x anywhere. So what we need to do is Math 9 in our calculator. So you can use Math 9. There was actually a question on one of the calculus message boards I'm on, and they said, would you have to do one of these really complicated ways to solve this by hand when students have to do that in the AP exam? The answer was no. Sometimes you might see a multiple choice question where it says which is the correct setup of the arc length formula, or if it's a more simple one to actually calculate. So here I'm in Math 9 and I've got 1.479. 1.479. There you go. So that is the length. Y equals x squared. Actually, you know, that's a parabola, right? Between 0 and 1. So you're talking about that length. That's pretty cool that you can find that. Find the arc length of y equals the sine of x between 0 and pi. So again, fill the pieces in. Length, 0 to pi. 1 plus, now the derivative of sine is cosine, quantity squared dx. So if I rewrite this, length from 0 to pi, 1 plus cosine squared of x. Now, you're looking at that, you're thinking, hey, is there something I can do to solve that? 1 plus cosine squared, it's very tempting to think of that with your Pythagorean trig identities. And off the top of my head, I'm thinking, all right, sine squared of x plus cosine squared of x is equal to 1. And then sine squared would be equal to 1 minus cosine squared of x. But that's not what I have here. I have 1 plus, so it's not a Pythagorean trig identity. That doesn't work. Close, but not quite. So again, I'm just going to use Math 9 on my calculator for this one. It doesn't say that I have to do this by hand. It doesn't say fundamental theorem of calculus. So I'm going to do this in my calculator. Make sure you're in radians if you are a physics student. I know that your calculator bounces back and forth between degrees and radians. Degrees for physics, radians for calculus. This is what I'm typing in. I don't even know if you guys can see that. And then I've got 4.712. If you take note in my calculator, it looks like the x is being squared in that cosine piece. But in calculator world, in TI world, that actually means that the cosine is being squared, not just the x. If you were to handwrite that, I would think your x is being squared, but it's actually cosine. All right, here we go. given, and by the way, just because, reminder that this is what sine looks like. Here's 0, here's pi. So the length of that curve is 4.7. Given the piecewise function, find the length of f of x over the given interval. So it looks like we're going from -2 to 4. All right, let's set up a couple integrals here. Hold that thought. All right, given the piecewise function, find the length of f of x over the given interval. So I am going to need 3 different integrals. I can't think of any other way to do that. So the first piece, I'm going to color code this. We are going to integrate between -2 and 0. And it's the square root of 1 plus. Now we want the derivative of that. So it's 3x squared plus 1 quantity squared dx. She's going to erase the whole thing and I don't want to, but that's okay. All right, plus, let's pick another blue. Plus the integral from 0 to 2 of the square root of 1 plus 2x quantity squared dx. Plus the integral from 2 to 4 of the square root of 1 plus 4 squared dx. All right, I'm actually going to start on the end. That's the easiest integral. 4 squared is 16. 16 plus 1 is 17. So this is the square root of 17 between 2 and 4 dx. We can actually do that by hand. To integrate the square root of 17 is the square root of 17x between 2 and 4. So this is the square root of 17 times 4 minus 2, which is the square root of 17 times 2. All right, easy peasy, no problem. Now, if I come to the middle integral, we're integrating from 0 to 2. 2x squared would be 4x squared, 1 plus 4x squared dx. And again, it looks like I could use substitution, but there's no 8x hanging out. There's no x anywhere. So I'm going to do this in my calculator. Math 9, 1 plus 4x squared, comma, x, comma, 0, comma, 2. I've got 12.6 repeating. So 12.6. and 12.6. All right, and finally, this one in the beginning. If you wrote all of this out, goodness, -2 to 0, you could FOIL out this piece on the end. It's not going to do a thing for us. -2 to 0. Our old textbook, our old examples had some crazy like factoring things that you could do with some of these, but the examples I'm seeing on our notes right now don't look that involved. So I'm not going to go there. So let's do math 9. Square root of 9x to the 4th plus 6x squared plus 1, comma, oops, let's close that. Comma x, comma, -2, comma 0. And I'm getting 10. I wonder if that factors. Oh, this is a +2. Oh, shoot, that's a +2 on the end. Hold that thought. Typo. 10.34. Okay, so if we add these together, +2 square root of 17. I've got 31.253. Remember, 3 decimal places for the AP exam. So given the piecewise function, find the length of f of x over the given interval. I think that's what we're doing. Now I'm just checking, this is kind of a bit of a review, checking to see that this is continuous. If I put 0 in place of these first two functions, I do get -3 and -3, so it's continuous there. If I put 2 into both of these, 2 squared is 4, 4 minus 3 is 1. If I put 2 in here, 4 times 2 is 8, 8 minus 7 is also 1. So it is a continuous function. I won't mess around with the derivatives to know if it's differentiable everywhere, but it's continuous, and that's all we need to know. So there you go, 31.27. So another formula to use and know, and yes, memorize. Remember, there's no formula sheet for the AP exam. I know that you've had the advantage of using your notes on assessments and all your classwork, which is great and wonderful. But when we get to the real thing, every derivative has to be memorized. Every integral is memorized. Every arc length formula, every volume formula. So make sure you're working on memorizing those.